Hello everyone, in today's video we are going to solve this question. Okay, so here the question is, prove that the sequence whose nth term is an is equals to root over of n+1 minus root n is bounded, monotonic and convergent. Okay, so let us prove this. Answer. So here the first bit is showing it monotonic. Okay, so now we know that here an is given as root over of n+1 minus root n. Okay, so we will rationalize it for easily solving this question. Okay, so let us rationalize this. This one is root over of n+1 minus root n by this is into root over of n+1 plus root n. Okay, and this is root over of n+1 plus root n. Alright, now this is equals to how much? This is root over of n+1 whole square minus root n whole square. Okay, and this is by root over of n+1 plus root n. Okay, now this is equals to n+1 minus n by root over of n+1 plus root n. Okay, so from here this plus n minus n will cancel and we are left with, so we got an is equals to 1 by root over of n+1 plus root n. Okay, now let us find an+1. Okay, so an+1 is equals to, substitute n by n+1 in order to get an+1. Okay, so we will get this as root over of n+2 plus root over of n+1. Okay, or let us first substitute n. For n is equals to 1, let us take n is equals to 1 for finding its value. Okay, then a1 will be what? 1 by this is root 2 plus root 1, which is equals to 1 by 2.414, because its value, root 2's value is how much? 1.414. Okay, and from here an+1 we will get a2 is equals to, for n is equals to 1 only. Okay, for n is equals to 1, from here we will get a2 as 1 by root 3 plus this is root 2. Okay, so this is 1 by root 3's value is how much? 1.732 and root 2's value is 1.414. so this is how much? 643.146. okay, so this is near about 1 by 2 and this is same as 1 by 3, isn't it? Now see, now we know that 3 is greater than 2, isn't it? So 1 by 2 will be greater than 1 by 3, isn't it? As its value is how much? 0.5 and 1 by 3 is how much? 0.33, isn't it? So what we can see that 1 by 2 is always greater than 1 by 3, isn't it? So from here what we got? a1 is greater than a2, isn't it? So therefore an is always greater than an+1. Okay, so from here what we got? That the sequence an is monotonically decreasing. Okay, hence monotonic. Okay, so the first bit is proved, that is the sequence an is monotonic. Okay, Now next let us prove its boundedness. Okay, so we know that an is equals to 1 by root over of n plus 1 plus root n. Okay, so this is always greater than 0 for all n. Okay, because here n is what? Any natural number. So this is always positive. Okay, hence being positive, this term is always greater than 0. Okay, so now see, this an is always less than 1 by root over of n plus root n, isn't it? Okay, you can prove this. You can prove that one by using this same thing. Okay, take here, let n be 2. Okay, then this will be what? Root n plus 1 plus root n will be how much? This will be root 3 plus root 2. That is 1.732 plus 1.414. That is 6, 4, 11, 3, 3.146. And here root n plus root n means root 2 plus root 2, isn't it? That is twice of 1.414, which is how much? 828, 2.828, isn't it? So here see, now this value is greater than, for this value is greater than this value, isn't it? Now see, 1 by 2.828 is greater than 1.3.146, isn't it? So we prove that this one is greater than this, hence this is equals to what? 1 by 2 root n. Okay, now this is always less than 1 by 2, isn't it? If n is equals to 16, okay, if n is equals to 16, then root n is how much? 4, isn't it? So 1 by 2 root 16 is how much? 1 by 2 into 4, which is 1 by 8, and its value is how much? 0.125, and the value of 1 by 2 is how much? 0.5, isn't it? This is greater than this or not? Then see, we got the upper bound as 1 by 2. So from this we got the upper bound of the sequence an as 1 by 2, and the lower bound is 0. So from this we can see that the sequence an is greater than 0 and less than 1 by 2. Okay, for all n. Hence the sequence an is bounded. Okay, now let us proceed to the third bit. So here boundedness is also proved, and the third bit is convergent. So we know that this sequence is monotonic and it's bounded also. Okay, so any sequence which is monotonic and bounded is convergent. Okay, so see, it is convergent. We know that an is convergent. Okay, the sequence an is convergent, and it's convergent to what? Let us find. Okay, so limit n tends to infinity, an is equals to limit n tends to infinity 1 by root over of n plus 1 plus root over of n, isn't it? N is infinity, so 1 by infinity is what? 0. So the sequence an is convergent and convergent to 0. Okay, so we proved all these 3 bits. Okay, so hence this question is proved finally. So this was all for today, and if you like this video, then please do like, share and subscribe my channel. And thanks for watching. Thank you.